In this lecture, we're going to be introduced to haloalkanes more officially. This is going to be our second functional group that we look at in the course following alkanes. And as such, we need to provide a proper introduction. The approach I take is one that I think many people take to kind of teaching functional groups and how I introduce them. And so it'll be kind of a pattern, not just as we wrap up this course, but moving into organic chemistry too. Every time we introduce a new functional group, we need to kind of talk about some basic attributes of it. So the next functional group is the haloalkane. Okay, so haloalkanes are alkanes with halogens. Alkanes with halogen atoms. And so the halogen atoms I'm referring to are fluorine, chlorine, bromine, and iodine. And for this class, our favorite one is bromine. It's right in the sweet spot of reactivity. It's reactive enough to do interesting things, but it's not so reactive that it doesn't spontaneously decompose. Chlorine, on the other hand, is a little bit kind of a less reactive, and same with fluorine, whereas iodine is too reactive. Okay, so with this in mind, and these are also alkanes, I should add, so they've got carbon, hydrogen, and sigma bonds. So only carbon, hydrogen, along with sigma bonds, and then there are one or more halogen atoms present. What we need to start with is IUPAC naming. So we're looking at if we have a halogenated alkane, how do we approach naming the molecule properly according to IUPAC rules? And so what we have to recognize is a lot of it is very similar to alkanes. And the only major difference is that we now have halo substituents. So the halo substituents, these are the groups now hanging off of the ring that are halogen atoms. And so we could have an F on our parent chain, and that would be a fluoro group. We could have a Cl off the parent chain, and that would be a chloro group. Br would be bromo. And then I for iodine would be iodo. So it's naming molecules like what we have been doing with IUPAC naming, except now we have halogens present. And so if you have something like this molecule where we have an iodine on a cyclohexane, we would call that iodocyclohexane. And so the halogen atom is a substituent on the parent chain. And so we just could have parent chains with halogen atoms hanging off of them, and we just need to include them. And so for this first example, you could also have 1 in front of this to indicate the position. Although if it's just a number 1 and there's not a number 2 present for a ring structure, IUPAC many times likes to let you get away without the number 1. Let's look at another example. Let's say we've got the molecule pentane and we throw a Br in the middle of it. We would call that 3-bromo pentane. And if we had multiple halogen atoms, we could call this 2,2-dichloro, and sorry, that shouldn't have a real hyphen. That's just me running out of space. Dichloropropane. So we could have our dies, tries, tetra, prefixes in front of our substituents, which are now halogen atoms, along with a number for each of them. And if I had to have a fluoro example, I guess maybe I could have tetrafluoroethane, and that would be 1, 1, 2, 2 hyphen tetrafluoroethane. Okay, if you notice, there's no space between the halogen and the parent chain once we get to that last substituent off of our parent chain. So there's no space in one iodocyclohexane, and then hopefully the others are somewhat clear. And there's also only hyphens when we have numbers going to letters. So this is a lot like what we had looked at with naming alkanes. We just have these new substituents present. I should add, though, that if we have an opportunity to have a chiral molecule, we can include that now in our name as well. So for example, if we look at this molecule, we would say that that molecule is 2-bromobutane. Okay, if we number the molecule in such a way that we reduce the substituent number, we would want to number from right to left in this case. And so we would have the bromo at the 2 carbon. So this is 2-bromobutane. But keep in mind now, this is a stereocenter. It is a carbon atom with 4 different things attached to it. And because it is a stereocenter, we could have instances where we've got a wedge on the carbon attached to the bromine. And so if we number this 1, 2, 3, turns out that in this case we have the 4 priority, which is a hydrogen atom, and back. And so this looks like an R. This looks like it has an R absolute configuration. We could actually include that in the name. We would say that this molecule is R with parentheses around it, 2-bromobutane. 2-bromobutane, and it's the R. So the R kind of indicates the stereochemistry, in this case at the only stereocenter. If you wanted to be absolutely explicit, you could put 2 in front of the R, and that can be helpful for allowing you to see where the stereocenter is. So that's acceptable, at least in my playbook. Maybe some folks don't like the number if there's only one stereocenter, but it doesn't matter to me. I think the number can be helpful because if you have a situation where, let's say we've got a Fisher projection now, put H's on the vertical. So it looks like we have an R stereocenter at the fluorine. Ooh, this is a tough one. This is a tough one because I'm going to put it here. I'm going to do this. Okay. So we have an R stereocenter at this position in our Fisher projection. We have a S stereocenter at this position. Now this molecule actually corresponds to, let's go ahead and do it. So Fisher projection. We've got a carbon chain that runs through the molecule. Just like this. So that looks like 1, 2, 3, 4, 5. So we have 5 carbons. And then one of the carbons is a fluorine. I'm going to guess that that is a wedge. And then at the other carbon is a chlorine atom. And I will guess that it's a dash. Now, if we check, we have 1, 2, 3. That looks to be R, whereas chlorine now is 1, 2, 3. That's R times -1. So this one is S. So I have the correct structure. Now, the way we would name this structure is we would again want to make sure that we give the substituents the lowest number possible. So this would be 3-chloro, 2-fluoro. And I put the chloro first over the fluoro because C comes before F in the alphabet. And this is pentane. Okay. Now what we have additionally in addition to all of this is the stereochemistry. And so we would say that this is a 2R 3S molecule. I put everything in parentheses, separating the letters and the numbers by commas, and that takes care of the stereochemistry. Now, if we just put R and S without the numbers, we wouldn't know the position of the R stereocenter and of the S stereocenter. So fairly complicated example. I probably didn't need to go into showing the Fisher projection first, but it's one of those things, you know, we had to learn it. Let's use it. Let's look at another example. Let's say we've got I, B, R, B, R. So in this case, I could start at 1 and then 2, but that would give me a 1, 2, 2 numbering because both of the bromine substituents would be 2s in that case. I don't want to do that. Instead, I want to reverse the numbering so that I have bromine with a 1 and iodine with a 2. And so this would be 1, 1 dibromo. And let's put some stereochemistry for the I. 2 iodo cyclohexane. You won't believe, well, you can probably believe, but there's a lot of times where people get really mad at me because they're like, why or they just draw a straight chain. They ignore the cyclo. I won't even tell a story. Okay. So if you see the cyclo or if you see a ring, make sure to include the cyclo. If you're reading a name and converting it back into a structure, make sure to include, make sure to pay attention to the word cyclo. Okay. Now in this case, this looks to be another R stereocenter. So I'm going to put 2R in front of this. Okay. Should we do another practice? One, let's have a smaller ring. Okay. So this looks like a cyclobutane, and it's fluoro, 1-fluoro, 1,2-dimethyl cyclobutane. Now you might be wondering, why did I put the fluoro, which starts with an F, in front of the dimethyl, which starts with the D? Well, remember, we ignore the di, tri, tetra, and just go right to the substituent, or the functional, or the group that we're that's hanging off of our parent chain, which is methyl in this case. So F beats M in that case. Okay, so we have 1-fluoro, 1,2-dimethyl. What about stereochemistry? This looks to be R. This looks to be S. You could prioritize that if you needed to. So then this would be 1R, 2S, 1-fluoro, 1,2-dimethyl cyclobutane. Okay, that gives the lowest numbers. That includes the stereochemical descriptors. And the RNS assignments has the di for 2 methyl groups and has the parent chain, which in this case is cyclobutane, a 4-membered ring. Okay, so I mean, with naming, I think it's always a good, healthy place to start when we're learning about a new functional group. You know, this is one of these things where it's hard at first, but it's a systematic set of rules that were defined by us. So it is something that can certainly be learned with enough practice. And so there should be some practice on the worksheets. Go ahead and give it a shot.